Good morning. Here is Chapter 2 from the textbook Fezden and representative carbon compounds, functional groups, intermolecular forces, and infrared spectroscopy. Let's begin. Carbon-carbon covalent bonds. Carbon forms strong covalent bonds to other carbons and to other elements such as hydrogen, oxygen, nitrogen, and sulfur. This accounts for the vast variety of organic compounds possible. Organic compounds are grouped into functional group families. A functional group is a specific grouping of atoms. Carbon-carbon double bonds are in a family of alkenes. An instrumental technique called infrared spectroscopy is used to determine the presence of specific functional groups. Hydrocarbons, representative alkanes, alkenes, alkynes, and aromatic compounds. Hydrocarbons contain only carbon and hydrogen atoms. Subgroups of hydrocarbons, alkanes contain only carbon-carbon single bonds. Alkenes contain one or more carbon-carbon double bonds. Alkynes contain one or more carbon-carbon triple bonds. Aromatic hydrocarbons contain benzene-like stable structures that we will discuss later. Saturated hydrocarbons, alkanes, contain only carbon-carbon single bonds. Unsaturated hydrocarbons, much as appears in crude oil, contain double or triple carbon bonds. Alkene, alkynes, aromatics contain fewer than the maximum number of hydrogens per compound, capable of reacting with H2 due to the unsaturated carbon-carbon bonds to become saturated. Representative hydrocarbons, alkanes. Principal sources of alkanes are natural gas and petroleum. Smaller alkanes, C1 to C4, are gases at room temperature due to their light molecular weight. Methane is a compound of the atmosphere of many planets, a major component in natural gas, produced by primitive organisms called methogens found in mud, sewage, and cow stomachs. Alkenes. Ethylene, is a major industrial feedstock used in the production of ethanol, ethylene oxide, and polymer polyethylene. Propene is also very important in industry. The molecular formula is C3H6, and it is used to make polymer propylene and is the starting material for acetone. Many alkenes occur naturally, such as beta-pinene, a component of turpentine, and an acid alarm pheromone. Alkynes. Ethyne, acetylene, is used in the welding of torches because it burns at high temperature. Many alkynes are of biological interest. Capelin is an antifungal agent found naturally. Dactyline is a marine natural product. And estradiol is a synthetic estrogen used in oral contraceptives. Benzene, a representative hydrocarbon. This molecule is very important to discuss. Benzene is a prototypical aromatic compound. The Kekulé structure, named after Orgainc Chemistry, who formulated it, is a six-membered ring with alternating double and single bonds. Benzene does not actually have discrete single and double carbon-carbon bonds. All carbon-carbon bonds are actually equal in length, 1.38 angstroms. This is because the length of the carbon-carbon single bond and the carbon-carbon double bond are now fused. Resonance theory explains this by suggesting there are two resonance hybrids that contribute equally to the real structure. The real structure is often depicted as a hexagon with a circle in the middle. Yes. Molecular orbital theory explains the equal bond lengths of benzene by suggesting there is a continuous overlap of p orbitals over the entire ring. All carbons in benzene are sp2 hybridized. Each carbon also has a p orbital. Each p orbital does not just overlap with one adjacent p orbital overlaps, but with p orbitals on either side to give a continuous bonding molecular orbital that encompasses all 6 carbon atoms. All 6 pi electrons are therefore delocalized over the entire ring. This results in the equivalence of all carbon-carbon bonds.